Good and welcome to video 12 of Agile Algebra. In this video here, we're going to look at a system of equations that has nonlinear equations. And as always, pause the video and give it a go first. I'm going to give a couple of hints as to how I solve this problem. We look at two different approaches. If you don't want to hear those hints, then maybe pause the video now or mute it. So the first hint I'd give is that you can rearrange the equations into a quadratic form. So eliminate one of the variables, choose any one of those variables to eliminate, substitute one equation into the other and turn it into a quadratic where one of the letters is the variable and the other letter is just treated as part of the coefficients. So treat it like a constant. So if you can get one variable in terms of another, solving a quadratic using the quadratic formula, then you'll be able to solve this problem. Hint number two, I do an alternative method where I let x equal r cos theta and y equal r sine theta. So I actually make a trig substitution to solve this problem, and it turns out it makes the equations a little bit simpler. You end up having to solve for theta and for r first before you can find your x, y, and z. So anyways, give it a go, either one of those methods, or maybe you've found another way to solve this problem. And then after the intro music, take a look at the two solutions that I go through. This problem here is a little bit more difficult than some of the ones that we've been featuring in this series. Good luck. So, first up, if perhaps we write one equation in terms of the other, and then we do that again and eliminate a variable. So if I substituted equation 1 into equation 2, let's just label these equations. So if I substitute 1 into 2, I've got z squared minus x squared, which is our y squared term, equals x times z, an equation that's just got x's and z's in it. And that is a quadratic equation, so I could rearrange it. Z squared minus x times z minus x squared equals 0. And then from that, I could make z the subject and treat x as a constant. I will treat it as a coefficient. So what I mean by that is I could say like a is equal to 1, b is equal to minus x, and c is equal to minus x squared, and use the quadratic formula. So if I go and solve this, z equals x plus or minus root x squared plus 4x squared all over 2, and this simplifies. You need to do a little bit of work with surds, and you can simplify it down to 1 plus or minus root 5 over 2, all multiplied by x, which is a simple linear equation. Z is some constant times x. In the question itself, you're not told whether x, y, and z are positive numbers or not. But you've got equation 2 there that's got y squared, which is a positive. So if you choose x to be positive, then z would also have to be positive. Or other way around, if z is negative, x would have to be negative as well. So if we look at switching to decimals now, because they're not nice solutions. So if I could rewrite this one as just considering the positive root 1.6180. I could do some more decimal places if I needed to, multiplied by x. And then equation 1, if I go y squared equals z squared minus x squared, and then substitute in my newfound expression for z in terms of x, that comes out to be 1.2720 x. If I was to, I'm going to have to square root that. So that's my y value. Okay, and then the last term is, last equation to use is x plus y plus z. The sum of the three solutions is equal to 10. So I can take these expressions x, y is 1.2720x, and z is 1.6180x, and that will make equal to 10. And then I can solve a linear equation from that and get x equals about 2.5707. There's a bit of rounding involved here. And y and z can be found using those extra equations. Y is 1.2720 times x, that comes out to be 3.2699, and z comes out to be 4.1594. Now, a different way of approaching this is actually to use trigonometry. It seems a little bit strange to do so, but if I make a substitution, x equals r cos theta and y is equal to r sine theta, and I substitute these expressions into the first equation, I get r squared cos squared theta plus r squared sine squared theta equals z squared. And because cos squared plus sine squared equals 1, this factor cos squared plus sine squared equals 1, meaning that z is equal to technically plus or minus r, but we will just go to consider it being a positive number. Now if I use equation 2 and I substitute in my r sine theta again, so I've got r squared sine squared theta, which is our y squared, equals x times z. Well, x is r cos theta and z is equal to plus or minus r. Then I've got an r squared on both sides, which I can cancel, and I've got sine squared theta equals cos theta. It's up to you how you go about solving sine squared equals cos theta. One of the ways is to switch it to tan. The sine over cos is tan. Or you could use a quadratic equation. I think that's probably the easiest way of going about it. If you switch the sine squared to 1 minus cos squared using a trig identity, and then you have a quadratic equation, cos squared theta plus cos theta minus 1 equals 0. That's going to give you two solutions to it. If we consider, so by the way, I was saying there's a plus or minus in here, so this plus or minus thing would have impacted my quadratic equation having a plus or a minus in front of that cos theta, and I'm only considering the plus here. When we solve this quadratic equation, we get cos theta equals 0.6180, cos theta equals minus 1.618, and it turns out that one doesn't work. You can verify that, but this one does work. And then when we find out the theta value for this, we take the cos inverse of it, and that gives us theta equals to 0.9046 roughly, of which then we can find out the x and the y values. So we take our theta to be that. Remember that z was equal to r. So we've got x is equal to r cos theta. And substituting in that theta value, we get 0.618 times r, and then we do the same thing for the y. Y is r sine theta. We find the sine of that angle, sine of 0.9046, and that comes out to be 0.786 r, and then z was equal to r. And now we can add those three expressions together because we know they all equal 10. So we've got 0.6180 r plus 0.786 r plus r equals 10. Solving that gives us an r value of 4.1597, and then we can substitute back up into our x, y, and z equations, and that will give x is equal to 2.571, y is 3.270, and z is equal to 4.160 to 3 decimal places, which is what we got as before.